Hello everyone, let's take another step forward in our discussion on position and displacement. Last time we talked about the position of Grayson with respect to Shelby, and that was this green vector here, and we said that that was 6 meters to the right, so 6I meters minus 1J meter. That's the position of Grayson with respect to Shelby. But let's take another look. Let's talk about the position of Adam with respect to Grayson. Right, this position of Adam with respect to Grayson. Well, that would be a vector like this. Not a very good drawing, but you got to get the idea. So I'm going 2 meters to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9 meters up. Right, so 2 meters to the right plus 9 meters up. Okay, and again, I can get that by taking the position of Adam minus the position of Grayson, right? So 4I minus 2I is 2I, and 3J minus a minus 6, so minus a minus, that becomes plus, so 9J meters, right? So that's the position of Adam with respect to Grayson. Then if I said, hey, what's the position of Adam with respect to Shelby? Well, that would be a vector along here, and I can get an idea here. 1, 2, 3, 4, 5, 6, 7, 8 in the I hat direction, plus coming across and over, so plus 1, 2, 3, 4, 5, 6, 7, 8 in the J hat direction. Right? So 8I plus 8J. That's the position of Adam with respect to Shelby. Now, one of the things I like about this subscript is if I'm adding vectors together. So for example, if I take the position of Grayson with respect to Shelby plus the position of Adam with respect to Grayson, I actually get the position of Adam with respect to Shelby. And take a look. The position of Grayson with respect to Shelby, 6 in the I. Let's just look at the I direction. The position of Adam with respect to Grayson, 2 in the I. So 6I plus 2I gives me the 8I. And then if I look in the J components, minus 1J plus 9J is a positive 8J. So when I add them together, that works out that way. Well, what can I do? I can write the position of Grayson with respect to Shelby plus the position of Adam with respect to Grayson, and that gives me the position of Adam with respect to Shelby. And what I like to do is I look at the subscripts. I get a G over an S and an A over a G on the left side of the equal sign, and I think of multiplication, even though I'm adding, but I'm going to think of multiplication. That should be a G. And the G's cancel out, and I get Adam with respect to Shelby. And so when you add vectors together and they use a relative position or relative motion subscripting, then when you add them together, the subscripts will cancel out to give you that final subscript. So this is one of the reasons I like the relative motion subscripting. Again, we won't do much more with that until we get to dynamics, right? So I did want to introduce it early on in this statics lesson. So you're going to see it again in dynamics, but we'll talk about it in more detail then. All right, so there's just a little bit more information on relative motion. If you have any questions, please put them in the comments below. Thank you.